All right, so we have two people that have joined us, Charlie. I know we're looking for a few more, but I don't know if you want to just get started or.
Up to you. Whatever you want to do. No, we've had a delay, so whatever you want to do.
Let's give it a few more minutes, I think would be good. We are recording now, so everything we say will and can be used against us in a court of law. So
When you guys publish this, do you take off the preamble and just um, edit it so you don't have the filler time at the beginning?
we'll have. I don't know. We'd have to ask Linda about that. I
Okay.
don't know if they edit it or not. No, Linda says we don't really edit it. So,
Okay.
oh,
Well,
they said go ahead and get started.
all right.
All right. Well, thank you everyone who are patient with the delay. We had a few technical difficulties, but we're back in action again. Want to just remind you that this session will be going to 11:30, and at 11:30 we have a Meet the Author session from 11:30 to 12. So you're more than welcome to attend that. You will miss the coffee break. The coffee break is from 10:20 to 10:30, so we prefer you to stay in the session. So we appreciate that. But do plan on attending Meet the Authors at 11:30, and then and I hope you enjoy this presentation. We've got John Mead, who will introduce Charlie Berger. And John, it's all yours. Thank you very much.
Thanks, Donald. Welcome, everyone. I think this is going to be a really interesting session. It covers a lot of technologies that I'm interested in, so I'm very excited by it. Apologies, we've had a few technical difficulties on the way, so we're a little bit delayed. We will lose a bit of time through the presentation, so Charlie will be going at a good pace through the slides. My role is I'm CEO of a company called Rittman Mead, who is an Oracle data and analytics company founded all the way back in 2007. And we've been working with Oracle's data warehousing, data integration, analytics, ML, AI, and similar products sort of, pretty much since that time. And over that time have sort of been or got to know Charlie over those years. I think Charlie joined Oracle in about 1999, so it sort of predates us there. His job title there is the Senior Director of Product Management, Machine Learning, AI, and Cognitive Analytics for Oracle Server Technology. And Charlie's sort of support, pioneering in the area, and been a sort of constant presence in sort of pushing the sort of Oracle technology and message in and around this sort of whole area of analytics and ML and AI sort of within the database and sort of in the sort of supporting technologies as well. So it's been a sort of pleasure to work with him and a sort of honor to introduce. So without further ado, I'll hand over to Charlie. I think I have to click the screen, right?
All right. Thank you for that introduction. Great introduction, John. And I'm sorry I can't be there physically with all you guys. Now you guys always run a great event, but these are different times. It's kind of interesting having John be my host here because I just was John's host a couple of days ago, 2 or 3 days, just recently, last week, I guess, for something we were doing. And he was speaking about the importance of metadata, and I think that's a very related kind of thing here. As you get more into machine learning, you'll kind of find, the data and the quality of the data and all that does matter. And so I could tell you a million stories about that and its importance, but that's for another day. We're a little bit hamstrung on in terms of time. We're a little bit shorter on time, but also technology. But I'm hoping that we can still power through and you can do everything that we were going to do as planned, and I'll show you how to do that. You can go. The idea is this is a live lab. You are supposed to be doing the live lab. Now, due to technology constraints here, I can only apparently show my PowerPoint. If I go to another screen, it doesn't seem to work out so well. So what I'm going to do is stay within the white lines of PowerPoint, but I have a lot of screenshots in here and some links, and maybe I can even copy and paste a link if you don't already have it. I think earlier on, Linda and company sent you out some links. If you click on those, you can actually just fire up an Oracle Live Lab, which is going to just wake up and give you all this instance for 4 hours and all this data, and you can just run with it and have a good time and follow along and do exactly what I'm going to be showing you screenshot by screenshot by screenshot through PowerPoint right now. So I just realized I may not get the builds to operate the way I thought they were going to do on here either. So let me try and go through this thing. I'm not sure if my little face window is, I'm going to put it down there so it's not in the way. So anybody that's running this thing, if I've got any kind of setting here that's not coming through right, please speak up and give me any kind of counsel on that. But I'm going to assume that you can see all this just fine. And so today's business problem is kind of interesting. I got this from Abby Hay initially, something we had already always thought about, but she actually did it once, and I said, oh, that's good. I need to do that too. And so the idea is that you are looking for fraud. We're going to say in this case it's going to be automobile insurance claims fraud, but it could be tax fraud, it could be healthcare fraud, it could be whatever. And we've got a set of sample data with about 15,000 records that's loaded up on the live labs for you to use. And we're going to do a two-step process. Why two-step? Because the first step uses what we call unsupervised learning, and I'll talk a little bit more about that, what it is, to flag things that the algorithm thinks are sort of unusual. They stand out. They look a little bit different than the rest of the data that it's looking at. It says for some reason, these records stand out a little bit. One of the punchlines in the story that you may find is that I think the number one most suspicious claim is a woman, single car accident. She's 26 to 30, I think, years old. She has a Honda Accord, and it's valued at over $79,000, something like that. Now, I don't know for sure, but I think if you look at the prediction details, why we say that could be suspicious. I think it's like a Honda Accord worth, $80,000. That seems a little unusual to me. It could be that the accident was like on a Sunday, and it might be your third accident, a few other different things, but I think that's the one that leaps out the most. The other ones are just possible things that could happen there. So we're going to use unsupervised learning to flag those records that stand out the most. Then we're going to curate those by going over to Oracle Application Express, and we're going to have we're going to play the role of an automobile insurance claims adjuster or investigator. We're going to look at all the claims. We're going to assign them to be, yep, that's fraud, or no, that's not fraud. So we're going to go through sort of a second step there doing that. And then once we've labeled the data, we're going to come back in and use Oracle Machine Learning Supervised Learning model to build a more precise model looking exactly for that. So that's the process we're going to go through, and we'll do that now. So there's this blog, and if you Google Oracle Machine Learning, and maybe if you put in these additional words, these are a few of my favorite things, you'll get to some of these links. Now, there's a presentation, there's a YouTube video, there's demo assets, but this was the earlier version of it when I submitted the information into Linda to have it mailed out to you. And in the last couple of weeks, maybe even days, it's gotten a little bit better. So you can go here, you can do everything, but you can also go to the same website, and a little bit further down on the page, you're going to see these. Oh, this is not laying out quite the way I had that. That sort of jumped down a little bit, but you're going to see these automobile insurance claims, supervised and unsupervised. And if you can go there and download these things and have them in your downloads file, you're going to use that later on. Okay, so follow along, but also in another window, please try to do these things. I'm going to go through the process again of what we're doing here and explain that again. So first, we're using the unsupervised learning algorithm, the one-class supported vector machine. We're going to flag anomalous insurance claims. How do we do that? It trains on what it believes you are feeding it. It believes that you're feeding it normal data. There's no fraud. There's no unusual stuff here. These are all just standard claims. Now, there may be, and if you know that these claims are in fact problematic, remove them from the training data set. So we're going to train on that. We're going to come back in and build supervised learning models now that we have labeled data, but we're going to use the expertise of a human or humans here, and we're going to serve up these suspicious claims. We're looking for needles in haystacks, so we're going to take all the possible needles that we've narrowed it down to the top 1, 2, or 5% of the data. We're going to put it in front of experts. They're going to combine the machine learning expertise with their own domain knowledge, and they're going to review these things. Maybe make some phone calls. Maybe visit the car or visit the accident and make it a determination whether or not they think that's error. Make a error again. Error again. I say abort, whatever that was. I have no idea what that's doing. So it's going to use the expertise of the domain experts to label the data. Once that data is labeled, it makes the machine learning problem easier, right? Now the machine learning algorithms can say, these are fraudulent, these are not fraudulent. Let's build a model that distinguishes the two of those. Then we're going to come back in and review those with better charts and graphs with Oracle Apex. And if we have time, we're going to go in and look at that in Oracle Analytics Cloud. And you can do everything except the Analytics Cloud off those live links or the GitHub link. So all this stuff is definitely supposed to be transferable to you. So the HOL environment that you want to go to, if I had the link here, and I'm a little bit hesitant to put that link in there, I'm just going to ask you to go to Google Oracle Live Labs. Google Oracle Live Labs. In that window over on the right-hand side, it'll say AI or ML labs, and in there you're going to want to look at the one that says the autonomous database for machine learning. I think it's what it's called. I got screenshots of it later on. And the builds are not working on here. What's it supposed to say? This is what we're going to do today. There are a bunch of other workshops like this that we're working in these live labs things. Here they all are, and these are coming. So it's supposed to be, if you want to, you can follow me on Twitter, and I'll post when those things are out. Maybe pay attention to that if you wanted to. So the HOL environment is this apex apps.oracle.com right here that I'm showing. You can just Google that and probably find the same one. And we're going to go to the same location. So just Google Oracle Live Labs, search for the machine learning one. It'll say AI machine learning. It's got about, I think it's like either 2,000 or I think it's got 5,000 downloads or something. It's the second most popular one out there, I believe. I have it on one of my other windows, but I'm kind of hesitant to jump around because I don't think you see that, and I don't want anything to break here. But when you go there, if you have an Oracle account, just log in, and it'll ask you it'll give you a PIN that you have to type in here, and you'll have to come back with that. If not, you may need to set up an Oracle account. You can do that now. It'll take you 2-3 minutes or so to do it, and then you're going to come into here and you're going to log in. Now, they changed this in the last week or two, and I think this is the most current version of what you would have. So you log in here. I already have an account, but when you sign up as a new person, you can just sign up with a new account. So depending on whether you have an account, you can log in with your own account or set up a new one. They're both easy. Take you a second or two to do that. So please do that now. And I can't see if there are any. I'm just looking at chat here. Machine learning on autonomous database? Yeah, of course, yeah. And it's free, by the way. Everything I'm showing you is free, and it's in not just the autonomous database, it's all databases. I'm showing you the autonomous database because it's the easiest thing to show, easiest thing to access. You just click and you go there. You don't have to install anything. It's straightforward, and it is where I think a lot of us at Oracle think the future is, in the cloud, and it's just so easy and straightforward. So yeah, that's what we're going to show is the cloud. There are, of course, equivalents of this on-prem with something called Oracle Data Miner, which is a little bit more mature technology, right? You have drag and drop GUIs, you have the integration with R there, the integration with Python is coming here. It's sort of in limited availability right now as we speak, so that's coming too. But we're going to the cloud because it's just where everybody's going, and it's straightforward and easy. So you log in with your account. Here's where you create a new one, if you need to create a new one. And once again, you sign in and you get a little PIN number that comes, your Droid or wherever, you type in the PIN number and now you're in. So I'd ask that you do that. And this is the one you want to get to. It's called Machine Learning on the Autonomous Database. Can somebody please type in here that they are following along, and it's worthwhile for me to go this sort of pedantically through every slide. Is anybody actually following along? Somebody is. Graham, good, thank you. I don't know if I can mention his name, but thank you. Anybody else out there following along live? Please say yes. Many of us out here are doing this. Otherwise, I got an audience of one, which is good. But anybody else out there? You can type in the chat window. Okay. All right. Good. We got a second person. All right. We have a crowd. Thank you. So you want to go to this thing. If you have any challenges with this, just say, yeah, I'm challenged. This thing's not working out. But this has been getting better and better and better, and I think it's really the easiest freaking thing to do out there nowadays. It's really straightforward, I think. So now you want to click on what we call this reserve workshop for live labs. I don't know why they call it reserve. It's just basically launch it. But I guess you can schedule it and say, I'll do it on Saturday. I always do it now. Now there is, you might want to take a screenshot of this and type in this little thing right here. This is what we did I did a hands-on lab last week, and it was organized by the Oracle marketing department. And they had this promo of some sort that you got 300, I thought it was actually 500 cloud credits that you can use, and it's just at that URL. I don't want to kind of touch too many things here and copy and paste that into the window because I'm nervous of what might go wrong. But if you take a screenshot of that, I think you'll be able to get in there and get, I think it's $500 cloud credit. So you can do this workshop, put in that, I guess you have to have a new account. Okay, you can't say, oh, I want to put a few more quarters into my existing account. You have to have a new account, and then you'll get the $500 of cloud credit. So you should be able to just like do this live lab workshop. After 4 hours, it will run out, and they'll just wipe it clean and start it up. Use that you start up a new one for the next time somebody wants to come in. And you could come in consecutive 4-hour things all the time. I've done like 20 or 30 of these things myself. But you can also just put in the credits and just keep right on going as your own account. So try that out. It's really getting kind of easy. So now you come to this next page where it says reserve, and you say, I consent to receive emails. You have to say that you're going to do this. It'll send you an email saying your instance is ready, or you can just watch it online. You don't have to go there, but you say, do it now. I consent, submit reservation. And when it does that, it will send you this notification. It'll give you the screen. Thank you, reserving it. We are preparing the instance. So what they're actually doing is firing up an Oracle Autonomous database just for you. It's a PDB pluggable database. It's just for you. You're going to be the admin on it. You're going to be the Oracle machine learning user, and it's just going to be your own session that you can play around with, do whatever you want for 4 hours. But we've loaded up some stuff for you so you can have things to do while you're there. It will now say watching, or watch here for your status update. When I've done this before, it's taken 4 to 15 minutes, something like that, maybe 6-7 minutes on average. This time it was 14 minutes. And that's while you're doing that, I'm going to go off and explain some other different things. So keep on coming back and doing this. And if anybody has it wake up and they're ready to go, please type in the chat window. I'm ready to go now. It came back fast. So give that give me an update on that as you go. So hopefully it's just going to. Okay, getting back 15 minutes. Okay, yeah, that's about right. There was a bug a couple of days ago, I'll just tell you about it in case you do run into it, that I think has been fixed, that if a bunch of people log in, now we don't have a crowd right now, but we had over 100 people in the other one, and we had like 300 people or 400 people registered, but like over 100 showed up, and then we said, okay, click now, and when we clicked now, there was some sort of bug because they were using the timestamp and a couple of different things to make you a unique person, but they all clicked at the same time, and it kind of threw an error for that. So it would say 15 minutes. When it got down to 0, it would go back up to 5 minutes, get down to 0, go back up to 5 minutes, and it kept on looping around. I think they have since fixed that, but if that sounds familiar, 15 minutes from now, you can tell me about that. Okay, so now you'll get an email that says, hey, your reservation is being processed, and we'll get right to you. And I did this on January 25th, and it gives you the time. So now, while we're waiting for those things to boot up, I'm going to come back and just cover some concepts, okay? We're going to use this time creatively to just talk about machine learning in general. We're going to do that for about, I guess, 14 more minutes or less. And please tell me if you're done, because we can skip over this stuff. I find it fascinating, but we can skip ahead if you want to. So the builds that I have here are not working. So some of these slides are going to be a little unusual, but I'll kind of power through them here as best I can. What I was first going to say was there's two different kinds of things, supervised learning and unsupervised learning. And the ones in the top 3, you're doing things where you have labeled data. Like I'm trying to identify the most important factors for people who buy Teslas, for people who have a negative response to the COVID vaccine, for people who have low, medium, high, or very high values for lifetime value. So whatever you're looking for, you can kind of figure out what are the factors most associated with that, the strongest correlating variables. If you're trying to So that's what a lot of people do. That's important unto itself. What are the main top reasons why people buy my shoes rather than somebody else's shoes? That kind of thing. If I'm a shoe retailer, if you're trying to predict an actual outcome or a behavior, like who's going to buy a Tesla car, who's going to which of these insurance claims are fraudulent or taxes are fraudulent. Given I have a lot of examples to train on, then that's called classification. If I'm trying to predict an actual value, that's regression. That's like what Zillow does, where it predicts the value of your home. If you're trying to segment things into different, those are all supervised learning because you have historical data, and labeled data is the key. We're going to do labeled data at step, if I call it at step 1B, I guess. So there's 1, unsupervised learning, there's 1B where we label the data, 2 is where we do the supervised learning, and 2B is where we visualize and investigate the data in Apex or Oracle Analytics Cloud. So when we don't have any examples, we're going to use unsupervised learning, the bottom 3, and we're going to spend most of our time with the solid squares, the anomaly detection, then that's going to be part 1. Part 2 will be the classification. But we could also, a lot of people for fraud, they'll use clustering, and they'll say which records don't really nicely map into an unsupervised learning kind of cluster. You know, I have all these people over here that are teenage kids with skateboards that like classical music. Well, as odd as that may be, there may be some people that kind of fit in that a lot, but there are outliers in some edges of what their characteristics are. And those people that don't quite fit into that little cluster, you might say, well, that's unusual. They don't really fit in with the rest of the people in this cluster. So people will also build a model, assign them clusters, which one or more clusters, and then use cluster distance. How far away are they from the centroid of that cluster as an estimation. Other people will do it a little bit differently. They will say, other people will do it a little bit differently. They will, whoops, I want to do this guy and turn that off. Other people will do it a little bit differently, and they'll say, I want to predict a value, like what's the value of this tax submission? And I'll say, well, it's $20 million. I'm trying to get a rebate for $20 million. And they'll say the distance from actual to the prediction. So that's another way you could do it using a regression model. But we're going to do the classification, the anomaly detection in the reverse order here today. But my point is there's a lot of different things you can do. Now, this slide is a whole lot better when it's in build, but I'm not getting the builds happening here. I don't know if it's me or the Bizabo stuff here, but here what it's supposed to show is a cloud of people that are red and blue, and you try to fit the straight blue line, the dotted blue line through it. It doesn't do a very good job. You try and fit a more curved line, the black dash line, and it does a little bit better job, but it doesn't do it as well as you'd want it to do it. You do the next build, and it shows the decision tree where it sort of carves out these little arrows, these little areas here. I don't know if you see my mouse or not, but all these little boxes here. The decision tree finds a cut point, makes a split decision, finds another cut point, makes a split decision, and keeps on iterating until it kind of ends up with these homogeneous subpopulations that are what are the stopping criteria for the decision tree algorithm. And the nice thing about a decision tree algorithm is they also provide these sort of very human readable rules. Now we have something else called prediction details, which is kind of similar, but that's it's one of the most easily understood algorithms, and it's when you are trying to find patterns using labeled data. So we have a bunch of data, they're labeled as triangles or round circles, and you're trying to find the patterns. So that's pretty straightforward. And one of the things you'll hear me echo many times, and I think John can probably echo this as well, is I see, and I think he probably does too, a lot of people who know a lot about Oracle and know SQL and know how to use the database, know all sorts of clever things with the database, but they think they have to hire a data scientist that has a PhD in mathematics or machine learning and knows Python or SQL or TensorFlow. And I'm here to say, since we've moved all the algorithms inside the database, we try to make it simple. It's a very natural evolution for an Oracle data professional to simply add machine learning concepts and be able to just keep right on going. So these concepts that I'm kind of trying to pass along right now, I think are very understandable. And most of my customer references are people that started out as not as data scientists and learned about the database. There are people who knew about the database and learned about data science. So if you're one of them, I think you could have a very fun time doing all this stuff. Okay, let's keep going. Now, what do you do when you don't have very much data? It's hard to fit a pattern through 1 or 2 or 0 data points. So that's where it gets a little bit squirrely here. So what we're going to do is we're going to use some basic concepts here. We're going to go back to kind of early childhood days, and we're going to say, remember that guy Waldo? Now, I did check. This is apparently international hopefully in the Rocky Mountain area, you guys have heard of Waldo. I think everyone has across the planet. But there's this kind of strange looking guy, and he's got a hat and glasses and a cane and everything. And you usually find him at the beach or in a large crowd or at a outdoor market or something like that. And you have to find him, but usually you can spend all day finding him. Well, what if you only had 10 seconds? So we're going to kind of take that right now. Now, I think with the build, it's probably going to point exactly to where Waldo is. That's, as I think ahead, it's going to say, there he is. So imagine this without the build. Okay, so let's click next. And I'm going to give you 10 seconds, but it's not going to really be 10 seconds. It's going to be 3, 2, 1, find Waldo. Well, there the build is. So there's Waldo right over there. But how does your brain work to find something in a crowd like this? Well, a lot of times, if you know what you're looking for in supervised learning, you'll say, well, find all these little striped shirt guys. Everybody that's a striped shirt is what I'm trying to find, or find that hat or the cane. There's another striped shirt. But oftentimes, what you're first looking at is you're looking for what stands out. Well, I have a little room up here, a lot of people standing around. I've got a guy on a bicycle over here. I got a table of food over here. I got certain things kind of stand out. You're looking for what stands. There's a woman, I guess, with a kid pulling back the curtain there. So you're looking at somebody else pulling somebody's clothes. Never noticed that before. So you're looking for what kind of stands out. But what we're doing with anomaly detection is we're looking for what stands out and then taking all those things that stand out and setting them aside, and we're going to review them as humans. So that's what we're doing with anomaly detection in principle. Now, there's another, and if I did this live, I could actually play Big Bird singing here. I'm not going to sing the Big Bird song here, but hopefully you also remember this song. One of these things is not like the others. He's got 4 bowls of birdseed here, and notice 3 of them are identical, but this one's different, and Big Bird notices that, and he starts having this little sort of learning song. One of these things is not like the others. One of these things doesn't belong. Can you tell which thing is not like the others by the time I finish my song? And that's the concept. So anomaly detection can be simple. Just think about Big Bird. And so we're going to go look at that again. The builds are not working here, so this is kind of taking the fun out of some of these things here. But the idea is that you have lots of data. You're looking for needles and haystacks. You have lots and lots of data. Somebody in the chat window, tell me if your things are back live again, please, also. So you have lots of data. You have few or zero examples of what you're training for. You have many attributes, and for any one single attribute, like this one right here, it's a little bit on the high end of age, income, whatever this variable was. It's a little bit on the high end here, on the high end there too, but none of them by themselves is enough to trigger you to say, hey, pull this one over, investigate this one, because none of them by themselves are enough. Some of these things might be all straight down the middle, and you might say that's just too normal. It's just people are not that normal on all these different dimensions. So so 5 minutes left. Good. I hope it gets down to 0 and works for you. But in a multi-dimensional, multi-peculiar way, the algorithm is going to look for things that are unusual, and it does that by first training on what you call normal data, and then applying that perception of normal to a new set of data, either the same set of data and saying, well, of these guys, which are the most unnormal or not normal or whatever, dissimilar, or a new set of data. So that's what you're doing. And here was another one that's a whole lot better with the build. But this is my own credit card a few years ago when I got this fraud in here. I don't know if you see the fraud. It's much better with the builds. But people always would say, oh, it's the Monaco thing. Somebody stole your card and used it internationally. No, I actually went to Monaco, actually for Oracle Business, and I had a great lunch and a great bottle of wine, and it was a blast. But that's normal. This is on my own personal credit card. Then I started having these charges at the local mobile mart. Now, if you look that up and use geospatial as another field or so, you'd say, hey, that's a part of northeastern Connecticut that I live outside of Boston. I haven't been over there for years. I rarely go to that part of the state, actually. And suddenly I'm over there a whole lot, which could be another input variable. But also notice I'm suddenly doing all these purchases at gas stations. I'm hanging around gas stations an awful lot. And so that's another thing that's a little weird. I don't know if you noticed, these are timestamps, 205, 206, 1148, 1149. They're all in pairs of purchases. They're also all the same dollar amount, 75, 75, 75. That's if somebody's just punching in 75 on my card all the time. And if you used SQL windowing averages and such, you could see the total purchases exceeds my moving average for the amount of spend I was doing at gas stations. So imagine doing this kind of logic. I know some restaurants and some hotels that do this kind of stuff for looking for anomalous records for, like, you stay at the hotel, you run up this bar tab, you run up this meal tab. These are kind of unusual things. This is what American Express and people like that do. And actually, we have We have a public reference called Certegy that's out there. If you Google the Oracle machine learning references, it's out there, and they do check fraud. You write a check, and what's the likelihood this check that I'm writing, I just wrote a check in San Francisco for lunch, and now 5 minutes later I'm writing another check in Atlanta for lunch. Is that normal? So they use us inside the database, and that's the kind of thing you'd be doing here. So before you get too far down this machine learning path, what I always like to say is, and there's a whole blog series I have out there. If you go to those blog links, you'll hopefully see this. I see a lot of people evolving from Oracle data professionals to Oracle data scientists, and I have this sort of series of steps that is nothing special. It's just what everybody in the industry says, which is start out with a well-defined business problem. It's part of this CRISP DM methodology they have that's kind of been around for years. And what it really says is the old Albert Einstein kind of theory. If I had an hour to solve a problem, I'd spend 55 minutes thinking about the problem. What's the problem statement? What are you really looking for? What do you consider to be fraudulent? What do you consider to be unusual? I had somebody at a hospital in Los Angeles, a children's hospital kind of place in Los Angeles. They were looking for anomalies in infants in the neonatal unit. And I have no idea if a blood pressure of 120/80 is normal or deadly for an infant, right? So you have to have the data. You have to know what is normal. If you're trying to do it as an anomalies, train on normal and flag things that are dissimilar. If you have all sorts of examples of what you're looking for, then that's a different kind of problem. It's supervised learning. And you have to think about the problem statement, be very crisp in that statement, and we can talk about that as a whole other adventure, but then make sure you bring in the right data. Don't just take the data you have and off you go. That's going to get you chasing your tail. You want to think about the problem. I'm trying to find people who buy, who default on a loan, or people who have done automobile insurance claim. Well, one of the variables you might want to have is, have they ever submitted a claim before? Have they ever submitted a fraudulent claim? Has any member of their family ever submitted a claim before? How many claims have they submitted in the last year, in the last 5 years, and on and on and on. Think about the data that you want to assemble. Don't think about the data that you have. Okay, I don't really care what the date and timestamp is for when they filed the claim. I want to know more. What's the length in time between when the accident happened and when they filed the claim? So think like a cop, think like an investigator, think about what are the variables that you would want to get your hands on, and that's what Albert's trying to communicate here. So let's go into product details real quickly. Somebody says, give me any updates if you guys get in. Okay, I'm waiting for updates on that stuff. So what are we talking about? We're talking about Oracle Machine Learning. It's part of the database. It's a free feature of the database since December 5th, 2019, so a little bit over a year ago. I think it's one of the big secrets out there. People still don't even realize this stuff's free. Spatial and graph were also made free features. I guess Larry and Oracle company kind of decided, that it's just kind of hard to sell these technical advanced things through a generic Salesforce as little one-offs and little additional, a la carte things. It just makes sense to sell the database as much differentiated converged database strategy, which I love, because it just keeps on saying, you get this database that it's a Swiss Army knife of capabilities. Look at all the amazing things you can do with it, and these are some of the things I think that are just very amazing. And if you have the always free tier of the autonomous database, you can do this always free. You can do all this. You can set up a whole little application flagging fraud. Okay, somebody's got the workshop launched. Good. I'm going to speed it up then. So launch the workshop. I'll be right with you. This is also a public service announcement, is what I always say, because a lot of people don't know it. So, one, we try to make it simple because we move the algorithms to the database. You don't have to schlep the data out of the database to do the math. And two, and that changes everything. Architecturally, that's where most deployments of machine learning fail. With the Oracle database, you're already done, because you built the model inside the data into the database where the data is, and you apply the model, move the model to another database, whatever you want to do. It's just standard IT technology at that point. And so it's free, which is the second really cool thing. Want to contrast just briefly the different architectures. Everyone else does it sort of these best of class, all these different kind of things. Oracle has this converged database that is JSON, graph, spatial, network, image, machine learning, all this different stuff in there. It's just, it's like your Droid or your smartphone, or it's just a collection of features that is much more powerful than all these separate things where you're schlepping data back and forth. So let's see what else we have. So the algorithms that we have are plenty. We have over 30. I think it's up to maybe 35 now. We just added in XGBoost, MSET, SPRT. We have some. We're integrating with Python that's in limited availability right now. We put So you can use the native SQL to access these things. We also interface with open source R. We can use R language to drive these algorithms, or you can just do callouts to R and do R things. Similarly, you can use Python language to access these functions or do callouts to Python. And we also have a drag and drop GUI Oracle data miner, and we have the notebooks that we're going to use today. One of the other really nice and special things about this is everything that we're doing here inside the database can also leverage all the rest of the database functionality, like partitioned models. I want to build a political model of who's going to vote for which candidate, and I want to partition it by state and gender. Easy. I can handle transactional data. So in a medical situation, it may be the medications, and every time you get new medications or new temperature and pressure readings, just add them as transactional data. We aggregate those and we bring them in as a vector into the algorithms. Similarly, unstructured data, we use Oracle Text to tokenize all that. So by bringing the algorithms inside the database, it just opens up all these doors. And it's just a smarter, better, simpler mousetrap. So we can access the functionality via the drag and drop GUI on-prem with Oracle Data Miner, part of SQL Developer. We're not going to do that today. We're focused on the cloud stuff. We can do these new Python, Zeppelin notebooks. Python is coming to these notebooks. It's in limited availability right now, so I don't want to put a date on it, but any day now. Oracle machine learning notebooks are available now in Autonomous Database. That's what you're going to use. On-prem, we have the R Studio, which can drive these algorithms from the R language. We sort of map the interfaces together. And the Python will be coming on-prem, and the R will be going to the cloud. And we have a new user interface that's going to not be quite that style, but it's called AutoML user interface. That'll be coming up to the autonomous, I guess I'd say roughly this spring. So what we're going to do now is use the notebooks. We're doing this automobile insurance one. It comes with the autonomous database. It's designed for collaborative use with different data scientists and users, and you can immediately set up jobs and run them. There's 9 example notebooks. I'm going to point you to those. We're mostly using, we're using SQL and Markdown language right now, but the Python is coming to the autonomous database very, very soon. Days or weeks. When you get into here, what I'm going to point you to is the different example notebooks. So you're going to click on example notebooks, and you can click on when you select them and then create a notebook from that. You can open them up and read them, but you can't run them because they're hardwired, or they're not allowed. You have to make a copy of them, and then you can run that. So and under the hood, what we're doing is I want to just kind of communicate the ease and simplicity of this stuff. We're doing anomaly detection under the notebook or under the GUI or under the button or however you interface this. It's just running a little bit of code here. DBMS data mining create model. We're doing create model 2. That's the name of the model. That's the type of function. We're using this. The target field is null, so we're actually doing classification, but there's no target field. So it's going to say, aha, you want me to use the one class support vector machine here to do that. And then we build the model. It'll build in a few seconds, and then we're going to apply the model. And that's all it is. So if you read SQL at all, those people who do say, "Oh, I get it. That's pretty straightforward," and that's our intention. So now today's workshop. Hopefully, I see one person here. Graham has gotten it. Hopefully, Sandra's gotten in. Anybody else out there get in? Please give me a little feedback on that if you could. And we're going to go down into the notebook land now. So you want to launch your notebook. Click on that. Your 10-15 minutes should have gone by. You're going to launch your notebook, or you get an email that says your Live Labs environment is ready. Then you're going to get to this screen, and you're going to want to remember your admin username. Like this one, they're always going to be LL, and this is 2008. Remember the 2008 is what you have to remember. You can write it down, remember it, whatever. You're going to copy the password. On the next screen, they're going to ask you to change the password. So you're going to copy this. You're going to give it a password that you can remember, like welcome 123 or something, whatever you want to use there. And then you're going to need to remember this because you're going to have to search for that later on in a drop-down menu. So let's see what the next screen says. The next screen says, okay, get started. Now, the reason I'm showing this is there are other live labs. The one I did a week ago had, it was a different use case, and it's all documented as part of this live lab. So if I were not here as a human, you could just simply file all along these things and click next, and it walked you through each step with a lot of screenshots and sometimes little videos. So Oracle's been putting a lot of energy into these live labs, and frankly, I think they're great. So you want to now log in. At the bottom of your thing, it's going to say you're not going to do your single sign-on. You're going to log in with the Oracle Cloud infrastructure, your OCI direct sign-in here, not this federated kind of thing, but your OCI direct sign-in. So it's going to remember that, whatever your username was. And I must have did a screenshot that didn't link up with the previous screenshot there. I guess because this is a slightly different number, but it'll be the same number you saw over there. You want to paste your assigned password right here. And then the first thing it's going to do is ask you to change your password. So do that. Pick something you can remember, because you don't want to not be able to do the lab because you can't remember your password. Now you come into here, and I just took a lot of screenshots. So I was planning on doing this all live and just follow along, but I've got so many screenshots. Hopefully it'll feel a little bit like the real thing. So you go into here, you click on this little hamburger guy up here, I think is what we're going to do, and it'll come up and show you, where you're going to go. We're going to click on that on Autonomous Data Warehouse, and then it's going to, whoops, I got to click over here. So now it's going to take you to a page that doesn't look like this yet. It's going to be blank over here, and it's going to have, well, where is it? Which one is it? You're going to have to click on that little guy right there, and you're going to have to wait for it to say like a directory, and it's going to give a whole list of like all the other live labs that are running concurrently right now. Find the one that you have. This was 2008 LL Live Lab 2008. Find your particular one. Click on that. If you don't do that right, you're not going to see this. If you click on that right, you're going to say, there's the autonomous database I just fired up for you. So make sure you do that. I'm just going to assume that all of you guys out there are doing this successfully, and then you're going to click on that. You're going to go to the service console, and you're going to see the autonomous data warehouse is up and running. It's available, all set and ready to go. We're going to click on the service console, and you can see how the database is running, what's going on. I want you to click on administration. When you get into administration, you're going to be presented with a number of different things here. Now, if you're using SQL Developer or something like that, you can set this thing up over here. If you're using SQL Developer or something like that, you can let my T go over here. I don't want to have to give me a minute here. Okay. So if you click on this, you can download the wallet and you can come on in with SQL Developer, things like that. You don't need to do all that because we've already loaded all the data up there for you. And we're going to come in and click on Manage Oracle Machine Learning Users. Why? Because as admin, we don't want to be, we want to be admin and be a special thing. So now we want to create mere mortal users like Charlie or OML user or whoever you want to create here. So we're going to click on that next. Now we're going to create a user. So when you click on this guy, I already had a Charlie user in here. So I'm going to click. It's going to pop up. It's going to pop up, and I'm going to give it OML user. First name OML, last name user, I guess. Put in an email, and then I would recommend you just give it a password there, whatever you want. Welcome 123 exclamation point, whatever you want. Pick something you can remember and create that. And then once you create that user, you're going to come back here, and that OML user will be here. Light that guy up. Don't click on him because you're still admin. Just select him, then click on the house, the home up here, and that will take you to the login page for OML user. So now you log in as OML user with your new password. So you kind of were authorized. We created you as a user. First you were admin, now you're OML user. You're ready to come back in and start doing some machine learning, and you'll log in as a mere mortal and you sign in. So now the very first page you're going to get to, which license do we choose? Which license? Where do you have a license? Where's it asking you for a license? I don't know what that is. Oh, if you can come on video or audio, just create autonomous. Well, let's go back. You don't have to. The autonomous database has been created for you. When you come back to here, remember, you come into here and you click on the autonomous database, right? That's where you're going to go to, way back to here, and then you're going to click on. Then you're going to click on right here. So you don't want to create an autonomous database. I guess you could, but I don't even know what happens here. The thing is, you'd have to wait another 15 minutes, so you don't want to do that. We've already set that up for you as a live lab, and in that live lab, we've done a lot of preparation for you. So we've loaded up a bunch of data for you to play with in the live lab. So you want to come over here and click on L2008. You want to do this little drop-down menu right here. Okay, it didn't load right away. Yeah, it doesn't load right away. It's a little bit of a delay there. Click on that, it'll drop down, and then you'll see, oh, that's the one I'm looking for. Click on that, it'll wake up and it'll fill out that thing right there, and then you'll click on that. So hopefully that gets you through that. Yep, got it. All right, good. And so now we come into here to the service console. Click on service console. Now go here, click on administration. Click administration. that will take you over to here, manage Oracle Machine Learning users. So hopefully people are there. Send me feedback if you are or not. We're just at the front door now, ready to go in. We've created our user, create a new OML user. We want to come in with like an OML user, give your email, give your nice little simple password here, and then we want to have created that guy, highlight him, click on home, and then we come into the front door now. So here we are logging in back to, and this is what I have bookmarked on my system, on my Chrome browser. I have a bookmark. I just click there, I log in, and it remembers my cookies and all that kind of stuff, and I log in here. So now we're logging in, and when you log in, you have this sort of environment, and you can click on this little menu over here. It'll show you. How do I do that next? Show that next. I guess I do show that. There's templates, there's home, all these kind of things. I'm going to go back to here. But you have, the other thing you can do is go click on examples, and it's a lot easier. I don't have a screenshot of everything I wanted to show here, but I have a lot of screenshots here. So hopefully we'll power through this thing. But you get into here, you can go click on that. You can go see other thing. Well, not this way. You can see, you have personal shared, you have examples, you have connection groups, you have jobs. So if I set up a notebook, I can say, I like this notebook of fraud detection. I want that to run every day at noon from now on, or at midnight. So these are jobs. It's sort of a little automation setup you can do here. I'm going to ask you to click on the example templates. You're going to see several of these. They're very straightforward. Why? Because I did most of them. Maybe had some help along the way to update them or whatever. But they're just basic kind of examples of what you can do here. And you can take any one of these things, open them up, and view it. What I'm going to ask you to do is take one or two of them and click on it. You have to do it one at a time. Select an example notebook and say create a notebook. I think it'll pop up and say, what's the name of that notebook? And you'll give it your own custom name. You'll click OK, and that will appear in your own space. So it says, this notebook was created in Project OML. Here's my project. So when you work with a bunch of different people, you can have different projects, like the fraud project, the targeting customers project. You get different members to those workspaces. You don't have to play with everybody all in the same workspaces. You can have controlled access to who you collaborate with in your data science projects. So it's a lot more than just like a standard Jupyter notebook. It's much more of the Zeppelin notebooks, and the work that we've put into them has a lot more of the back end and the community group collaboration kind of concepts embedded in here as well. Once you've created some of those example notebooks, you can go back and click over here. You've seen the examples, and what do we do next? Then we go into the notebook that we just did, the copy of the notebook, and if I click on that, I think is what I do next, then you can open it up and you can see what's going on. And so this might take a little while. When you first load it up, it wakes up a virtual machine, a VM, with the Zeppelin software on it. And that may take 1 minute, 2 minutes. Sometimes it takes 6 minutes, or well, not that long, but it might take. It says working on this. It'll start it up. So the very first time you fire it up, you may have a little bit of a delayed reaction. It's something we've had some feedback on. We're always trying to speed that up a little bit, but it's waking up that VM. So now you come into here, you have markdown language, you have SQL, %SQL, %script, you do different kind of things here. And I am going to, if you go back to here, if I click on this little guy right there where the little arrow is, I can say, well, I've got this notebook. This is one of the standard ones that come with the product. I'm going to click on that little arrow. When I click there, it's better when it's live. I can say run all paragraphs. I say yes. And then what it does is it just starts, it's much better when you see it live. It just starts going boom, 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 boom through all the paragraphs, and you can watch those. Now, I just wanted to kind of give you a teaser for what that is. I was planning on showing this part of it live, but as it walks through and you kind of look at it, each of these little paragraphs have like %script where we're doing PL SQL. I comment out some things sometimes where I need to, like over here. And you can literally just sort of read the SQL, run the paragraph. There's these little gears over here. We can change the width of this. I think this is a 7 and a 5 or something like that. This is a 6 and a 6. So the width of the paragraph, you have control over whether or not you run the paragraph individually or run all paragraphs from this paragraph and below, whether the paragraphs are markdown language, SQL, what interpreters we're using, our PL SQL, which we call script. We're going to have Python in the product in the limited edition. It's already there. So you just said %Python, and we'll add in %R soon. So, well, later on this calendar year. And so you can do whatever you want in here. Now, we're going to get on with the lab and try to solve a particular problem. But the point here is there's a lot of different example notebooks for solving all those mainstream kind of problems. Association rules, fraud detection, time series, clustering. And you just open up the examples. Most of my not most of them, many of my customer references are people that I've spent a little bit of time, kind of like what we're doing here. We've had some follow-on meetings, and just as they kind of get familiar with it, and they go, and you just say, take that example notebook, just change it to your, first make sure you can run it with the demo data. After you get comfortable with it, make a copy of it and point it at your own data, and off you go, and it should work. You may need to do some modifications on what the name of the target field is and the unique identifier, things like that, but it's very easily editable. So now back to our use case here that we're doing. I'm tracking us at about 35 minutes to go here. So we'll get through all this thing. So we're doing automobile claims fraud. First, we're doing unsupervised learning. So we have unlabeled data here, and we're going to go back and download. This guy should have been up there a little bit higher. We're going to download these two bottom ones. Now you can download all four of them. They'll all work in your environment for the next 4 hours. You can try the other ones as well. And I think I also, on that page, there might be a link to the PowerPoint that I used in this other very similar hands-on lab. I don't know if I want to clutter a whole mess of them up there. I might put this one out there. I might not. You can send me an email if you need a copy of this, I guess. Or it's in the Bizabo thing, so you're going to get it there too. So now we have this claims that pops up here. Now, if I can show this interactively, if you click on the little show editor or collapse editor, these little boxes up here, you can see the little syntax for putting in images in here. And I've seen some of my customers put in videos up here. Anything that works to communicate your point. It's kind of a nice little environment that you can explain stuff. Here's the business problem, and so a lot of people like notebooks, just like the reason we all probably liked our engineering notebooks back in college. You can write a lot of notes, graph some things, show some tables of data. It's very sort of straightforward. And what we're going to do first is we're going to use the unsupervised learning. So all of these variables in this nice, well-behaved little set of data here, week of the month, day of the week, make of the car, accident area, all these things are going to be what we're going to have for inputs. Now, some things to know about the Zeppelin notebooks. When I say select star from claims 0, that claim 0 is the data set that does not have any labeled data. Later on, we're going to use claims, which has another field that says fraud found, yes or no. Did the investigator say that was fraudulent, yes or no? Here, we don't have that field. We just say a bunch of claims data. I don't know which one's the weird one, what's unusual. But when I do a select star, the Zeppelin browser is only going to take the top 1,000 records here. So I can't take 10,000 records. If I want to show a representative sample, I can just add into here, select star from claims, parentheses, sample 10 or sample 2. Use the sampling function in the database, which is something we had implemented many years ago as we were starting down this whole journey with machine learning embedded in the database. And you just take a sample of it and view that. So be careful about a few things like that. When I do the same thing here, I say select star from claims, then I can also click on bar chart, pie chart, or whatever, and I have the option for laying out different graphics. Now they're limited. You cannot do box plots. You cannot easily do a histogram. You can do a bar chart. So it's not the be-all, end-all of graphics. I think the Zeppelin notebook widgets will evolve over time. We're leveraging open source right here, but we're also working in tandem with all the graphics and widgets and such you get with Oracle Analytics Cloud or Oracle Apex or any other data visualization tool you want to use, because the data and the insights are where? They're in the database. So you can use any SQL literate tool to do that. First thing you do with machine learning, second thing you do after you define your business problem is you typically want to look at the data. So I'm just doing some simple graphing. I'm taking select star from this. If I could show it live, I would be clicking on pie chart. I'd be dragging and dropping different fields into the group by and the X and the Y plots. You might want to play around with that. It's not, as I say, the most sophisticated, but it's rudimentary and it's enough. With machine learning, if you could solve your problem this easily with a few graphs, you wouldn't need machine learning. So we want to get a feel for the data, see if the data makes sense. And you could do this in OAC, you could do this in on-prem using the Oracle Data Miner, GUI. You can do this with a lot of different tools, but in the notebooks, this is what you're doing. And so after I can't do that live, so let's see. I'm down to here. So now when we actually build our models, we scroll through, and I apologize for not being able to show my screen, my instance with the Bizabo was kind of hamstrung this morning, so we're doing it just with PowerPoint here. But in your instance, you should see other paragraphs. You can kind of scroll on down. And if you click run all paragraphs, they should just be, bam, 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 going through. I don't know if it shows how long this took. It doesn't show it right here, but this should only take 1 or 2 or 3 seconds to build the model. And just like I showed you in the other screenshots, just begin, DBMS data mining, create model. There's the type of function null, there's a settings table up here that says I want to use a support vector machine. I want to have auto data preparation on. So if you have like data that you think you need to scale between 0 and 1 because you have income over here and age over there, and you think you need to have the algorithms also scale, we do that automatically for you with auto data preparation. You can always do anything manually if you want to, but there's no reason to do that. So there's two different ways of doing it: setting up and using, and maybe dropping and updating the settings table, or just sort of defining them on the fly. I've shown them both ways now. So now once you've built your model, you can just apply the model. As we see up here, select star from where, the probability of fraud using the claims model, okay, using the probability for this claims model, predicting 0, predicting unusual. So I've sorted everybody and I've said, show me the guys that stand out the most. So here is this, the one I'm always accusing, this 26 to 30-year-old female who's single. I didn't show all the other fields in here, but if you did, you might want to add into here the car type and the value of the car and a few things like that. Because I think one of the things that stands out in my mind is how do you get a Honda Accord worth over $79,000 or so. But we've flagged these guys in their ranking. We've put it at rank, like what are the most unusual claims, and what's the probability that we think this is kind of unusual. Doesn't mean it's a definite. We just that it's fraud. We're just saying it's unusual. It may not be a crime or whatever, but it stands out. So we've done that. We can explore this. There's a lot of other things you can do over here where I'm saying just display the top 5, maybe start graphing the most suspicious claims. I can visualize. Here's the people that are 0. They are the suspicious ones, and the ones over here are the unsuspicious ones because we're predicting a 1. And as you can see, the sort of the age differences between people. You can do a lot of different, however you want to graph things. But we've done the hard math of flagging the ones that stand out. So we're just about done here. We're going to leave all of the suspicious, we're going to leave all the data in the database, but we've added in these probabilities of things, and now we're going to switch over and use the humans to take another pass at this. So I think we're going to leave that data in the database, and we're going to now have experts disposition the most suspicious and unusual claims. So we're going to come back in here with Apex, and if I had this live and I could show it live, I would just be clicking on here, logging with Apex. And I did this with this other guy, Do-Hoon Kim, who's a college intern kind of guy. And I'm not an expert at Apex or whatever. I can kind of muddle my way through it. But he and I together got this done, and he deserves the lion's share of the credit for some of the coolness of this that I'm going to show you. I come in here now, and in that blog that I showed in the early part, there's the blog just about the claims thing. There's a link to the GitHub files. And on the GitHub files, you can download this application that we built. So you can download the data, you can download the GitHub, from the GitHub, you can download the SQL, the application express SQL code and fire that up locally. And what we're doing in these live labs, we don't have that part of it set up yet, but we will be adding, our plan is to add more and more of this kind of ancillary functionality to the live labs, so you can kind of do multiple things, along the way. But so this, you'll have to just kind of trust me. We've set this thing up, and notice I have the prediction probability. I have these little nice faceted search type of things over here where I can say just base policy, vehicle category, and this is kind of fun because I can say, oh, I'm just looking for people that have 4 or more past claims who are where fraud was found or whatever. And I've added through machine learning these prediction probabilities. I even have these prediction details that tell you, it's kind of hard to read here, but if you can read that, it tells you the address change, the value was 2 to 3 years. So they changed their address in the last 2 to 3 years. That's a little bit unusual, not really, but it's a little bit unusual. If you add these things up, these are little tea leaves of the different reasons, the little pieces of evidence, if you had to take this to a judge to say why you think this one stands out. So that's what we're doing here. You can add in graphics. You can have application expresses, what do they call it, a low-code application. It's pretty powerful. And when you get your vaccines, by the way, we're going to have this on the Analytics and Data TechCast days next week. It'll be on the Thursday. We have some of the guys working on the vSafe, the application that when you do get your vaccine, if you're lucky enough to get one, my wife got hers. So you go to this application, vSafe, and you type in all your stuff on the Apex application. That's all done with the Oracle Application Express. So it's a very rapid, low-code development environment, and you can do a lot of cool things with it. I'm sure many of you on the call here probably know a lot more about it than I do. But we used it here, and what we also said was, notice back here we have suspicious claims chart. We have key factors, which I'll come back and show you in a minute. And then we have this auto claims report. So imagine this auto claims report is really like on your mobile device. And I go out to the car and I look around and I interview the person. I try to maybe visit the accident scene and I check it all out. And this was a no in the build. We actually click and then it changes to a yes. So it starts out as a no. I change this to a yes. And here's the information you can, pop up, and I click on this little pencil over here to edit that. So I edit that record. I, as a domain expert, add my judgment as to whether or not this is, claim fraudulent or not. So I'm on the verge of doing supervised learning now because I have I've added in labels from a human, and I say fraudulent yes, fraudulent no. And so now with that additional expertise, I can go back and pull out what kind of technique? Supervised learning. So that's what we're going to do next. We're going to come back in and do supervised learning because now we know what we're looking for. We've had humans label the data, but they were augmented through the benefit of the unsupervised learning to flag just the subset out of the many unwashed masses, if you will. We've narrowed it down to a subset of things. The needles are what we think are more interesting needles, and we've sifted through the top 2%, 1%, something like that. And now we're given our human expertise to declare those are fraudulent, yes or no. And now we're going to build a more focused model using supervised learning techniques. So we're back to our notebooks. Nothing different here, except the business problem is based on labeled data. So this is another notebook, and it says it's supervised learning. Everything's very, very similar to what we did before. Did some data understanding. I don't think anything changes here. What's different in this data is we now have, I guess I show it back here somewhere. I have fraud found. Yeah, fraud found right here. Yes or no. So I've added this through the expertise of the insurance claims investigators. I've added this column here that says fraud found, yes or no. And now, based on that, I visualize some of the data. I might look at the data grouped by fraud found, yes or no. So you can do a lot more interesting graphs here as well now that you have labeled data. But I'm going to come back in and use supervised learning techniques. One of the first things you do with supervised learning is you split the data into training and testing. So you'll randomly select, and we have a little bit of code here. Now in the GUIs, we do all this for you. And in the AutoML user interface that's coming this spring, you'll just click, and like 6 clicks, and you'll get all this stuff to happen automatically. And then it will generate the notebook for you. Or if you use the drag and drop Oracle Data Miner on-prem, or in Database as a Cloud Service, it'll have a little node that will just do all sorts of things under the hood. Here we're kind of opening up the lid of that node and seeing what's the code underneath, and some of that code is doing this. Now there are also examples out there on GitHub and the other examples that we have out there that show how to do this with stratified sampling in case you have a very unbalanced data set. You generally want to have something that says 50-50 fuel mixture, as close to that as you can in a binary case. And so there's examples of code. Here we're keeping it real simple. I think it's like 30% of the example, 30% of the data roughly is fraudulent, and the other 70% is not. So that's a pretty reasonable balance for the algorithms to kind of tease out the patterns there. So we're just doing a simple 60-40 split here. We're now going to do an attribute importance. Notice this is the same thing as what we did before. I can't in the screenshot, scroll down here, but the DBMS data mining create model, we're going to give it a new name, and underneath here it's going to say that mining function is going to be attribute importance. After I run that, which is only going to take a second or two, and you can run it live now, you'll be able to get the results. So here it is. So I'm doing attribute importance, select star from the claims data set, and the unique identifier is policy number, and the target column is fraud found, that yes or no. So now what we've done in 2 seconds on, like, it's only 15,000 records, but even if you have a properly sized data warehouse and millions or billions of records, and you're doing queries on that ordinarily, if you start doing machine learning queries or machine learning model building, it's very reasonable. It's going to take advantage of all the parallelism you have in the database, and there's hardly an incremental load. And if it takes you like 20 minutes or half an hour to build a model, just schedule it at night like you would for any kind of long running query. But here we've done a model, we've built the model, we query the model. When you query the model, see this DM $V, this little guy right here? That's the nomenclature we use for the name of the model view. So when we create a model, it's a model object, and you can interrogate that model object and say, well, what were the key attributes? What were the reasons why? What were the settings of the model? When you're interrogating that, it's the DM $, and some additional syntax. So you have to see the documentation to see, if this were an attribute importance, it's a little bit different than if it's a support vector machine. So it's a little bit cryptic here. Watch out for that. But once you get the hang of that, it's pretty straightforward. And as we add the graphical user interfaces in the front of all these APIs, it'll get easier and easier for you. But here we see the key factors. Next thing we're going to do is we're going to start building some models. We're going to build, I think in this case, we build 4 models, a random forest, GLM model, in the new AutoML that we have coming out, the AutoML user interface. I'll be showing that actually at the Analytics and Data Summit next week on Tuesday. If you want to see that, I'll be previewing that a little bit more. And that will run as many models are appropriate, given your objective function of what you're trying to do in the data set. So we'll just shotgun all these models in an intelligent way for you in the UE user interface. But here we've decided to build 4 models, and this is literally all I do here is I take this notebook, this paragraph, copy, paste, change these settings to generalized linear model, random forest, everything else stays the same, run, and look at 2 seconds, 4 seconds, it's running lightning fast. Now it's a small set of data, but it's also on a free instance, and it just flies through here. After that, I evaluate the data. So remember I had that holdout sample. I did a 60-40 split. Now I'm saying, well, let's score the data. Let's compute the lift. So DBMS data mining apply. So we're doing that, compute the lift, give it a name, give the test data, claims test data is the one we did in the 60-40 split. So I know this might be going fast, but you'll get the hang of it when you have the time to read through the code. And again, there is a graphical user interface coming that will make this even easier. Or the other one's on-prem, the Oracle Data Miner is what probably most people use most of the time today. But we've built 4 different models. We get to review the results of those models in something called a cumulative gains chart or a lift chart. So we've joined all those results together with a little bit of clever code I got from Derek Cameron, helped me with that little sort of join there. And then I compute a lift chart, and we've got this nice naive guess line. So if I didn't have any smarts of machine learning, it would take me 100% of the time to sift through all the data to find 100% of the fraudulent claims. Here with predictive modeling, I can go through a lot less of the data. This is not as high a lift as I might want or might have seen in other cases. Sometimes you get a really high lift, but it's definitely an incremental gain over the naive guess. So we've got a lift. I can go after, let's say, 50% of the population and get like almost 70%. So that's a lot better than going 50% of the data and only finding 50% of them. So this is where you make your profit. That's where you have your efficiencies. And the higher you can get this lift, the better. Now, how could you make the lift better? A lot of people say, well, try a different algorithm. And yeah, that might work. But really the better thing might be get some more data, get the right kind of data, find out, well, what was the dollar amount of the claim? How many, were there witnesses present? Anything that you think is a variable that you would like to put into the soup into the stew that the algorithms are kind of munge all over, add those variables, and that's how you'll get a better and better, more accurate model. It's all about the data and what we call engineered features. It's more that than it is about the actual algorithms. The algorithms are all going to be do pretty similar. So now that we've done that, we can display all the suspicious claims. We can drop the old model or tables here and create a suspicious claims table. So now we're just using that predictive model, claims class model GM, yes, saying yes, we're looking for yes, it is fraudulent. Using all the data, using asterisk means all the data in that table. You could say using just age and income or whatever, but the asterisk means use everything. So we're using all the input variables, make me a table that sorts everybody on the probability of them being fraudulent. Now, some of these guys are coming out as high as 100%, like, I really think that's going to be fraudulent. And we've got, many hundreds of thousands of records here that we're probably sifting through here. So I might want to go over to another tool to visualize this, and something like Oracle Application Express comes in very handy. So let's look at the same data using Oracle Application Express. And over here, I can now see, well, let's look at that, the suspicious claims chart or some of these other reports. Here are the key factors. Remember that that attribute importance that I showed you before were the key factors. Here, let's just graph it over here and put it on an Apex kind of report. If I want to do a fraudulent claims, the probability of it being fraudulent shown as a box plot grouped by sedan, sport, or utility vehicle. So I can do all sorts of if I had spatial data, I'd throw it with a map up. I'd throw a map up there. So you can do all sorts of cool things with this. I think you get to a certain point where you say, well, I can do a lot of cool things with Apex, but at least I have access to, and I know Oracle charges for it, but we're adding other live labs where you just kind of continue on and go into OAC. And if you have OAC or data visualization or whatever flavor or OBIEE for that matter. You can leave the data there. You might want to come back in and visualize this data using a more graphically oriented tool. So the nice thing that I should say right here is with the Oracle Analytics Cloud is we've been working with that team of people, another group within Oracle, and now they are doing this sort of integration, this handshaking between my stuff in the database and their stuff in OAC. So I can, from an OAC user interface, I can now register a model, and you see some of these models over here. I think this started in OAC 5.6 or 5.7, something like that, I think. They've been doing it for a little while now, and it is beautiful. You don't have to do that. You can just simply point at the table I created, but you can also find the model that I created and apply it from this user interface. So here, I'm just simply pointing at that same table I did before, that suspicious claims table over here, that suspicious claims right there. You see what it is. So I have this suspicious claims table. I simply drag, drop, put my variables over here. I have a really nice report. I can go through here with everything you get with OAC, and other people probably know how to drive this much better than I do, but I can start to put in filters up here. Click on, where do I click the filter? I drag that down a little bit, I guess, and put the filters in here. This is better when I can do it live. But I can come in here and now create some simple graphs. I can see my filters down here for each variable. I can set up a filter. I can have the filters kind of go across the top over here, and I can drill through. I can also use these little brushing things over here, which is my favorite thing. I can say, well, how about just the men, or just the females, or just the cars that are over $100,000, or whatever. I can start to interactively filter, do dynamic brushing, data labeling, different kind of things here. I don't know why that flashed, but it's really nice. And so the more you get into this thing, the more you just start creating really cool graphics. But you could have done all this stuff without OML or the autonomous database at all, right? But you just be doing simple graphs. Now we're looking at more intelligent graphs because we've sifted through large amounts of data. We've found patterns in the data using unsupervised learning techniques. We've added the expertise of domain experts to curate that and label the data in an intelligent way. And now we've done supervised learning on top of that, and we've applied the supervised learning models to now have, these are our predictions, these are our reasons why, and it's a much more enriched treasure trove of data and insights that you can kind of investigate interactively with something like Oracle Analytics Cloud. Got just a couple more wrap-up slides here, I think. This is the brushing one. If I could do this live, I think I just brushed these $30,000 to $39,000 cars over here, I think is what I did. No, the more than 69,000. Yeah, this guy over here. I just lit that guy up, and over here they all light up. So I could create a subset of those guys. I mean, I love brushing and data labeling. I used to have it in a previous life many years ago. We did this, and it was the most. Spotfire does this kind of stuff. All these data brushing, data labeling as a what do they call it? Democratized data analysis in a visual, interactive way is so beautiful, and being able to serve up intelligent predictions and insights for somebody with more domain experience to drill through that data, I think it's a really nice way for people to work in a collaborative way using the whole Oracle stack. So I know you weren't able to quite do this part of it in the hands-on lab because we don't have those live labs fired up just yet, but I did want to show you this a teaser on this because it's pretty cool, I think. Sort of in closing, there are all these links you can go to on that one page, what I'm calling my favorite OML links. You can also just go to o.com. There's also information there. There's links to the documentation down here somewhere. I might have updated this and organized a little bit more, but there's live labs. There's Ask Tom series, a whole series of things. Some of the other PMs have been putting out on specific things like how to do feature extraction or clustering, kind of more detailed things. There's GitHubs out here. There's just a lot of information out there. I do want to call your attention to I'm a co-founder and very active in the analytics and data Oracle user community, so it's very much like the Rocky Mountain one. In fact, I think we try to partner and know each other very well. We're going to do our analytics and data TechCast days next week, so if you can join that, it's all free, and you can go download the library of what we've already done out there if you're so inclined. Oh, there's the information on that. So just Google Analytics and Data Oracle User Community or just andouc.org. So that's another place you can go to. And there's the YouTube, there's the GitHub, and all of that stuff there. So that's a quick commercial on that. And with that, I'd like to thank you for your time. I'd like to thank you for your patience going through all this with a little bit of a delay. We had some technical difficulties. But thank you very much for your time and attention today.
Charlie, that was awesome, and I really appreciate that. Analytics is something I like, and I can't wait to go through this presentation again.
Who's speaking right now? Is that who is that?
This is Don Graham. I'm the moderator.
Don, okay. Okay, great, Don. There's another guy named Graham something else here too. There's two Grahams out there.
Yeah, he's been on several of the sessions that I've
more than one Graham out there today. I'm glad you liked it. Give it a try. I just think it's a lot of fun. I mean, and the fact that it's free, part of the database, and you can get these live labs. I mean, I don't know what else you're going to be doing this weekend, but I would assume you're going to be doing this all weekend long now. So have fun.
I've got so much I want to do with Oracle and everything like that. This is just what I was looking for.
Perfect.
And I can't wait to go through the presentation again. I believe anyone on this session is thinking the same thing. I love analytics, and I'm very glad you did this. Thank you.
Super. My pleasure. Sorry for all the technical difficulties here, but I think this will record it. Anybody that comes in on demand, I think it'll work out fine for them. And I hope the live labs work. Did anybody on the call get all the way through, or most of the way through the live labs? For the actual live, can somebody type in a response? Did the live labs more or less work for you? Anybody out there?
Yeah.
Yes, worked great. Okay, good. Thank you. Yeah, the live labs. There's more to come. We have one on wine, finding a good bottle of wine. There's one on targeting customers that have good payment credit. After a while, I create a lot of them, and they seem to me a little bit repetitive, because it's like we're predicting this, now we're predicting that, and they sort of get the same, but they're different storylines. We try to show off something different, and we hope to have a whole series of these things, and they're all free, and I think it's one of the best things Oracle has done in a while, making them so easy. Just click, off you go, and take a quick test drive for 4 hours. So please enjoy that, and send me any feedback of any kind if you have any. And thank you.
I'm glad they work with the free version of the Oracle Cloud and everything, because that's where I do a lot of my work out there to learn the cloud and learn all this stuff, is going through the free version instead of paying for stuff.
Yeah, if you took a screenshot earlier on, then you would have maybe gotten the $500 free credit thing, I think is what they're doing. But you could. I always say this. I think the future is some kid working in his parents' basement on some other part of the planet that's sitting down there going, "Hey, I have access to this free technology. I think I'm going to take and download a schema of the SAP expense report system. I'm going to build a predictive model on that, and I'm going to put up a website that scores everybody using my free system on the likelihood this expense report is fraudulent, and I'm going to charge a nickel per score." And I think you got all sorts of opportunities like that with this free technology. So have a go at it. How do you get the results from the ML notebooks into Apex? Good question. If you know how to use Apex, you just simply point at that table, because we created a table that has the predictions inside. So if you know how to use Apex, and I barely know how to use Apex, but I can do it. Yeah, all right, good. You just simply go in and find that. Now, the nice thing about Apex, I think, is that I think this is a feature, you probably know this better than I do, but I think I learned along the way. We're always kind of taught, don't persist tables, don't do a table, do views. And I think if you do a table, you get the automatic faceted search feature, but I don't think that works with views. So that little thing that I had all those little checkbox, that came automatically. But I think we had to make sure that was a table, not a view, for that. But, it's not so hard to use, and it's just amazingly powerful. I don't know why that makes sense, Graham, why that view versus table thing makes sense. If you know why. And the people I was working with that knew well, I guess I didn't talk to, David Peak. David Peak's out in your territory somewhere, so I probably should have just asked him, why is it a table or view? But yeah, I don't know either. But that's the way it behaves. But there are a lot of cool things you can do out there. What I like all about it also is the ability to make it mobile. And I haven't quite figured out how to do it mobile, but we're working on some other demo things. We're going to try and make it, on premise and then mobile, or, whatever. All right. Well, I don't mean to keep you guys any longer than we already have. Any other further questions? Otherwise, thank you very much for your time and attention today, and good luck using this stuff. Just give me a call, charlie.berger@oracle.com, if you have any questions. I'm happy to try and help, and good luck, guys.
Thank you very much, Charlie.
Yeah, thank you, guys. I'm just going to click out and say close window then, I think. All right, guys, thank you. Have a good day.